So 2.7 divided by 2 would give us 1.35. So now we know that 1.35 equals the growth factor raised to the 10th power. So this is again very similar to 1.35 equals x to the 10th power. So how do we eliminate that x? Well, again, we could do the 10th root of both sides, or more simply, raise both sides to the 1 over 10th power. So just to illustrate that it does the same thing, the 10th root of 1.35 would give us a rate of 1.03. If we did 1.35 raised to the 1/10th power, we should get exactly the same thing. And we do, 1.03, 1.030. So we'll just round to 3 decimal places we did before, 1.030. So x equals 1.030. So that means our growth factor is 1.030. So for Nevada, we would have P equals 2.0, if you want, 1.030 raised to the power of time. So this is the population for Arizona, and this is the population for Nevada. Now what we want to know is, will the population for Arizona ever be equal to the population for Nevada? In other words, will these two y values ever be the same? Guess what? We can solve for this graphically. Just to see if this is even worth considering, well, if Nevada starts at a population of 2, which is lower than Arizona's, well then they, in order to be able to speed up and catch up to Arizona, must have a higher growth rate. Well, they do. They have a 3% annual growth rate. So that means eventually, if this growth rate is constantly higher, then we should expect the two to be equal to one another. So what I'm going to do is I'm going to graph both of these equations and see where they intersect. Where do their y values come in common? And so I will also do 2 times 1.030 raised to the x power, and I'm going to set my window from, looks like it might take a while since the growth rates are really both pretty small, so I'm going to go out about 30 years just to see. And since they start at 2 and 5 million, I know that Nevada would at least have to catch up to 5.1 before they could possibly cross, but I'm going to set this at 10, and we'll say, okay, well, will that give them enough time to catch up with Arizona? And let's see. So not really. It kind of looks like, it actually kind of looks like they're not catching up right away. So I'm gonna change my window to maybe, let's do, I'll just go up to 50 just to see, and I'll take my years out to 50 as well, just so I can kind of get a good image way far out and see how long it'll take for these curves to intersect one another. So there is Arizona, here is Nevada. It looks like it's really going to take a long time, so I'm going to go out 100 years, and I'm going to take this up to 100. Whoops. So I'm going to take this really far out and see what happens. So after playing around with my window, I actually had to go out to 200 years, and I had to take the population up to 150 million. Now this may already seem impractical that the populations would ever get that big, but to theoretically be able to solve this problem, we had to do that, and that gave us this window. So here is Nevada's population, here's Arizona's, and you can see that as time passes, they quickly begin to pass one another. So I'm going to look for the intersection zone, and I find out that they intersect after 137 years. So X is my years, and this is after 2010, and the population for Arizona, which is the same as the population for Nevada, will end up being 115.7 million people. So of course we could probably pretty confidently say that all things the same, it probably would take a very long time, if ever, for Nevada to exceed Arizona.